Let's go over sheet 5B-4, last of the regular worksheets for the topic. Still have a review sheet to do in the packet, but we're almost there. All right, so this one definitely steps it up a notch. You really have to understand the basic relationships as far as temperature and pressure and dew point, how they all relate to each other. So if you struggled a little bit on this one, I understand. Just listen close and hopefully when I explain it, it makes more sense. All right, so conditions. It's now overcast and snowing. You observe that the air pressure is rising. How would you expect weather conditions to differ on the following day? All right, so the main clue we have here is what's going on. And so overcast and snowing, that tells us that there's saturated air. That's what makes it cloudy and makes it snowing. And air pressure rising. Now you have to think what type of air has higher pressure. Well, the two things we consider when we're talking about chunks of air is the temperature of it and how much water is in it. Now, high pressure goes along with cooler air. High pressure also goes along with drier air. Remember, oddly enough, dry air is heavier than wet air. So it's now overcast and snowing, but because the air pressure is rising, you know that cooler, drier air is moving in. That tells me that the temperatures are going to be cooler, the relative humidity is going to be lower, and those two things together tell me it's probably going to clear up. So you should have been able to do the temperature and humidity part, and those logically lead to the sky clearing. So it's probably going to stop snowing. You could have mentioned that too. Number two, a factory near your home installs new equipment which greatly reduces the solid pollutants it releases into the air. Those solid pollutants, we would call those aerosols. This is the smoke and dust and whatever else is coming out of this stack. How will this affect temperatures in the area? Well, if it was some chemical that was acting like a greenhouse gas, that's one thing. But we're talking about solid pollutants, the smoke, the dust, the particulate matter. And they tend to, like a dirty window, not let in as much light. So if you clean up the air and all of a sudden now more light can get in, that's going to cause the temperatures to get higher because now you increase the transparency, you're letting more solar radiation in, and if you get more energy from the sun, logically you're going to warm up. So there's number two. And number three, you observe that the temperature has dropped from 56 down to 47 between noon and 3 p.m. What can you infer, what educated guess can you make about the type of pressure system moving into the area? So the numbers, let's look at the numbers again. 56 to 47, so it cooled down a significant amount, 9 degrees, and it did this between noon and 3 p.m. That's the part that should kind of set off alarm bells for you. Between noon and 3, according to what we learned, the temperature should be going up. Normally 3 is roughly the hottest part of the day because we're gaining more energy than we're losing between noon and 3. So if the temperature is going down when we thought it would be going up, must be we have an air mass, a chunk of air, a pressure system moving in that is bringing colder air with it. So colder air, just mentioned this up above, colder air, is at high pressure or low pressure? Well, colder air is denser, and so what that tells me is it must be a high pressure moving in, because like I said, the temperature went down during a time period when normally you would have expected it to go up, so must be that colder, drier air is moving in. Number three, what can you infer about the type of pressure system moving in if this occurred between midnight and 3 a.m.? So same temperature change, but now instead of between noon and 3, we have it happening between midnight and 3 in the morning, 3 a.m. Well, what normally happens to temperature between midnight and 3 a.m.? It cools off because the sun's down. We're only losing energy back to space. So if it cooled down, when we expected it to cool down, that doesn't really give us any clues. It's not as helpful as the other one. The other one, something happened that we wouldn't have expected, so there had to be an explanation. This one just is a normal situation. This should happen. So we couldn't make an inference actually because we expect the temperature to decrease during this time period. And so, I mean, maybe a high pressure system moved in that could help it cool down, but we can't really know for sure because there's nothing out of the ordinary here. All right, number 4. So the dew point. Do you remember what the dew point is? It's not a number you can tell me right now. The dew point is the temperature that the air becomes saturated at. So the dew point, the saturation temperature, at a given place remained the same between noon and 3 p.m. So dew point tells you how much water there is in the air. It tells you the temperature you'd have to cool the air to for it to be saturated, and that indicates how much water is in it. So if the dew point stayed the same, the air's moisture content stayed the same because the dew point tells you how much moisture is actually in the air, and since it didn't change, the amount of moisture in the air didn't change. B, if the temperature changed in a normal pattern, meaning it warmed up from noon until 3 p.m., like we would expect, would the relative humidity be higher or lower at 3 p.m. than it was at noon? So in this situation, you can go all hypothetical, or I like to just shove in numbers so I can sort of think with those. Let's say the air at noon was half full. That's nice even to work with a number in my head. So if the air was half full at noon at whatever temperature it was, and then it warmed up until 3 p.m. Now, from what we learned, warmer air can hold more moisture. It's like a bigger container for moisture. It doesn't have to have it, but it can because it has more energy. So if you took the same amount of air, or the same amount of water in the air, pardon me, and now you warm that air up so it can hold more, it's going to go from being 50% full, half full, like I said, to less than that because now the air could hold more, but we didn't add more. So it's not as percentage-wise full. That's a tough one. So the relative humidity would be lower at 3 p.m. since the temperature, under normal conditions, rises away from the dew point between noon and 3 p.m. And the further apart the temperature and the dew point are, the lower the relative humidity. Now, I say that's kind of a tough one, but the reality is that's also the exact question I need you to understand at this point. When the air warms up, temperature and dew point get further apart, the humidity, the relative humidity goes down. I can guarantee you if I give you a test on this, which I will, that question or one's asking that stuff will be there. C, how has the probability of precipitation changed during this time? Well, if the temperature and the dew point are the same, the air is full, it's 100% humidity, chance of precipitation is very, very good. We just got done saying, though, that the temperature rose away from the dew point, so the temperature dew point difference increased. That means the air is less percentage-wise full and therefore less likely to leak on you as well. So the probability of precipitation has decreased. Number 5. Okay, you observe that the dew point is rising more rapidly than the temperature. Is the air moving into the area dry or moist? Well, dew point tells you what? Just got done saying this. Dew point tells you how much water actually is in the air. So if the dew point is rising, the amount of water in the air is also increasing. So the air moving in is going to be wet, moist, because the temperature dew point difference is decreasing, the dew point is rising. How does the relative humidity change? Well, we just said up here, the dew point is rising more rapidly than the temperature. So that means the dew point is getting closer and closer to the temperature. Temperature is always equal to or higher than the dew point. So if the dew point is catching up to the temperature, that difference is getting smaller, like we just said. That means your air is more close to being saturated, so relative humidity is increasing. And as the air gets closer to being full, the chance of it at some point over your head, up hundreds or thousands of feet, the chance of it hitting the dew point, becoming saturated, and droplets and snowflakes forming increases. So increases your chance of precipitation. Last one, referring to what we learned earlier about temperature changes during an average day, give the time of day at which the probability of precipitation is likely to be greatest. So during the day, it's coldest just after sunrise. It's warmest middle of the afternoon. That's what we learned in the insolation topic 5A. Now, assuming that we don't bring in a brand new chunk of air with more or less moisture and mess with it, we're just going to say, all right, there's a certain amount of moisture in the air. The most likely time where you're going to get precipitation is when the temperature and the dew point are closest. So the temperature has to come down closer to the dew point. So the most likely time for precipitation is when the temperature is at its lowest point and therefore likely to be closest to the dew point. So it's coldest typically just after sunrise because that's when it's the coldest and temperature is going to be closest to the dew point. If you think about what you've experienced in your life, more than likely, if you've had foggy rides in a car or on the bus, they've been first thing in the morning. Or if it's been rainy and snowy, it's usually when you come to school. That's why we look at the forecast in a normal year to see if we're going to have a snow day. And it usually snows about the time we're on the bus coming to school. It's just the way it is because that's when it's the coldest. All right, I hope we made some sense out of this pretty difficult worksheet. The next assignment's going to be doing some review, and we will have a test on this, or at least a quiz on this, early next week. Well, this might be next week already. Well, we'll have a test or a quiz on this real soon. So make sure you look over those relationships and you know what's going on. Thanks for watching. Keep sticking.